Hello everyone, welcome to this presentation. This time we're going to see how to connect an LCD display to a Raspberry Pi Pico using the I2C communications bus. In this video we will see first an introduction, then we will show how to do the wiring to connect the Pico to the LCD. We will also see how to do the installation of the libraries that we need to do the connection, and finally we will show an example about how to do our communications protocol in order to represent characters on our LCD display. There are other two videos in this series, Digital Electronics number 5, in which we have seen how to connect an LCD to a Raspberry Pi, and you can get more information about LCD displays. And then in the video Digital Electronics number 8, we saw how to connect an LCD to a Raspberry Pi via an I2C bus. So if you want more information about this topic, please take a look at these two previous videos. Just a quick review about I2C communication bus. Here we have the schematic of the communication. We have a master, which is our microcontroller, and then we have two lines, SDA and SCL, connected to the different devices with which we want to exchange information. And these two lines are connected to the power supply using two pull-up resistors. So I2C stands for Inter-Integrated Circuit. It's a serial communication bus developed by Philips in 1982. It uses only these two bidirectional open drain lines, SDA and SCL. Typically, it uses 7-bit addresses to handle up to 112 different devices, because we have 16 addresses that are reserved. And typically, the transmission speeds are 100 kilobits per second and 400 kilobits per second, but it can reach up to 5 megabits per second. As we have seen in this previous video, Digital Electronics number 8, we are going to connect our LCD display using this module here, which is based on this integrated circuit, the PCF8574, which is an 8-bit expander for I2C bus. So here we have the different connections that go directly to the LCD. Then we have several elements. We can adjust the contrast of the LCD using this potentiometer. We can activate and deactivate the LED used as backlight here on the LCD. And finally, we can select the address at which we are going to connect our LCD in the I2C bus by using these paths here, but by default we have this address, which is 27 in hexadecimal. So this is the connection to our bus. We have the line SCL, SCD, and then we have the input for the power supply and the ground. Here we have the information about how to select the address at which we want to connect our device. If we want other address different than this value here, 27 in hexadecimal, then what we can do is to do connections here on these paths. So if the input is, or the two paths are open, then it represents 1 at the input, and if we do the connection between the two paths, then it is going to represent 0. So here are the different possibilities and the different addresses that we can get. So by default, all of them are open. So it is the configuration 111, which is 27. Here we can see the pinout of the Pico microcontroller. So from all these pins, we need only this pin here, which is the 5-volt pin VBus, and then we have also the ground and this pin here, number 38. And then to do the connection to the I2C bus, we are going to use these other pins here, number 11 and number 12, corresponding to GP8 and GP9, which correspond to the line SDA, pin GP8, and SCL, pin GP9. And now the connection is as simple as this. We only have to connect the SCL line to the SCL of the microcontroller and the SDA also to the SDA of the microcontroller, and then connect the line VCC and ground to supply our adapter. Here we can see how we did the connections in our testing board. We have used this board in other examples on this series about the Raspberry Pi Pico. So we have other elements, but here we have our LCD display and we have the 4 lines going, 2 of them with the communication SDA and SCL to our microcontroller, and then we have the other 2 connected to ground and to the 5-volt line. Here we can see the aspect on the other side of the LCD. In order to use the LCD display with our Raspberry Pi Pico, we need 2 important files which are shown here. One is the LCD API.py, which is our library, so to speak, with all the commands that we can use with our LCD display. And then we have this other file important, which is Pico I2C LCD with the different definitions. This other file here is just the Python script to test our LCD that we are going to see later. Also, I have to say that I have obtained the 2 files from this link here, in which you can get also more information about this topic. Here is a close look at these 2 files. Here is the first one, Pico I2C LCD. So here we can see the different definitions. By default, we have this address 27, but if we need, we can change it. And then we have all the different definitions that are required to drive the LCD. And then in the second file here, LCD API, then we have the different commands that are sent to the LCD to do the different functions. And here is the sample that we are going to do just to show the operation of our LCD. Here we are defining where our LCD is connected, so it is connected to the I2C bus number 0. The pins are 9 for LCL, this is GP9, and this is GP8 for SDA. The frequency of the communication is shown here, is 100 kHz. And then also we are defining our LCD, which is using the I2C communication bus at this address 27, and then our LCD has 2 rows with 16 characters per row. So here is what we are doing to represent something in our LCD display. Here we are moving the cursor to this position to 0, then we are showing this string hello world. We are waiting half a second here, then we are clearing the display and then waiting also half a second. So we are going to see this message blinking on our LCD display. If you are interested in getting these files, you can access to my website. Here is the link, and then in the section corresponding to resources, you can get here at the bottom the files to drive the I2C LCD from a Raspberry Pi Pico. So here is the link, and then you can get the 3 files for your personal use. So now we are going to see how to do it in real life. We have opened Sony here to program our Raspberry Pi Pico. So we open our folder in our computer with the corresponding files that we have seen. First one is LCD API, so we open this one, and then we are going to save this file on our Raspberry Pi Pico. So for this, go to File, Save As, select Raspberry Pi Pico, and then we copy here the name lcd underscore API.py, and then we do the same with the other one. Go to our computer, Pico I2C LCD, and then we also save this file in our Raspberry Pi Pico. This one is Pico underscore I2C underscore LCD.py. And finally, we can open also in our computer the test file. So here we have our program that we have seen before, and we are going to do the blinking of the message hello world. So now we can just execute our program, and then we can see here how the LCD is working properly. So if we want, we can stop and maybe do some change. If we want to blink quicker, maybe we can do like this, waiting only 0.2 seconds, and let's try this. So we can see how it is blinking faster. Well, this concludes the presentation today. I hope it is interesting for you. Please let me know if you have any comment or question. Thank you very much for watching, and I hope to see you in the next video. Goodbye now.